Hello world, this is Chris with Elevations, doing another YouTube video teaching Python. This is class number 2. On this particular class, we're going to be going over while loops and looping in general. We're going to throw in some time and some pauses and some things like that so everybody can see what loops mean, how they work, and what you can use them for in your program. Okay, we're back at our command prompt or our terminal here. So this is actually on a Ubuntu system, but as we talked about before, you can do this in terminal on a Mac, or you can do it on just your basic terminal on your Raspberry Pi, anything along those lines. As long as you have Python installed and a couple dependencies, you can make this work. So let's go ahead and, as we've seen before, we're going to use nano and open up. Let's just make it a while.py, or for the sake of actual naming convention, let's just do loop.py. So I'm making a program that's going to be doing some looping. While looping, or in order to make a loop, you're going to use a number of different statements, and really the easiest thing to do is the word while. So that's while. Like say, while some condition is true. I can spell it right too. While some condition is true. So once that is met, being some condition is true, then everything underneath it will run continuously. Now, one of the issues is you don't really want to run constantly. You want to have a little bit more control over that, unless you have a specific use case where you want it to run just until you kill the program or until you kill the computer entirely. So let's say I want to make a program run 4 times. So I'm going to say, let's say I want to start the count as equal 1. So it's always going to be 1. Now, while count is less than, let's see, it's going to start at 1. So 2, then 3, then 4. Let's just go ahead and say less than 5, and they're going to close that out. And then inside of that, I'm tabbing over, so I'm going to do print, and then I want to actually print out that variable of count. So the very first time it runs, since we started it at 1, the first time it runs, it's actually going to be 1, so it's obviously under 5 already with that. So after that, in order to control and continuously count how many times this loop runs, we need to increment count. So in order to do that, we take count and we say plus equals 1. So that adds 1 to whatever count has been. And I'm going to go ahead and throw a comment on here. And this line increments the variable by 1. There we go. So now it's going to print that out when we run it. So let's go ahead and hit Control X. That closes. Save buffer. Yes. Loop. Okay, now I'm going to do Python 3 loop.py. See if that works. It did not. What happened? What did I type wrong? Oh, look at that. Yep, same thing. You got to make sure you do things right. I did not. I used the wrong indicator there, and I bet you if you knew anything about what we were doing, you said, yeah, I saw that. Why didn't you? Every once in a while, errors occur. Look at that. 1, 2, 3, 4. Cool. That happened. So notice it counts 1, 2, 3, and 4. It does not print out 5 because, let's see, because this only happens while it's less than 5. Let's see here if we want to do less than equal to. Control, let's see, close that, now run that. Look at that, now it does 1, 2, 3, 4, and 5. Notice that goes real fast and we don't have any way to see it operating. So if I want to say slow that down, I need to start controlling time. In order to do that, however, I need to let the program know or let the Python environment know that I'm using time and I need to import a library. So I'm going to import time. And in order to now slow this down, let's say every time I start or I make this loop occur, all right, get out of there. Every time I make this loop happen, I want to do time dot sleep. Let's do half a second every time I loop. Okay, so what this is gonna do, and let's just go ahead and write some comments, because I always tell everybody comments helps run the world. Actually, it really just makes it easy for you to identify what you did there and somebody else to look at your code and know what you did and why you did it. So I'm gonna say sleep or pause for 1/2 a second. Okay, so now if I run that, I'm going to exit, and then now I want to run the same thing. Notice how it slowly increments down. That gives me a little bit, and you can watch it as it goes, gives me a little bit of an ability to watch the program run, and that's something that I definitely like to be able to see, so it doesn't just execute immediately. Now let's go back and talk a little bit more about the while loop itself. Now, if we want to say control that a little bit more, let's do, let's open up loop pi. Let's see, what do we want to do? Instead of having it entirely be just based off of count, let's make it run off of user input. And we saw in class 1 how user input works. So instead of while of a count, I'll just say while true. Okay, so since true equals true, that means it's going to be running basically forever. Okay, so in order to ensure it's going to stop at some point and run in a controlled fashion, I'm going to take user input and I'm going to give a chance for it to break. So user underscore input equals input. So now I would hope from class 1 you've learned user underscore input. That's now my variable that whatever input is put in from the user. So when the user types something, that string of characters is going to be saved into the variable user input. So user equals input, and then obviously we need to open and close. Since we want to actually say something, we need to use quotations because we're prompting the user to say something. Enter the quit to exit. How's that? And then I'm going to put, I actually could spell it right, that'd be cool too. Put that space in there. And then, let's see, the next line, we're going to add an if statement. So if that variable that we declared earlier, user underscore input, equals quotation, Q-U-I-T, quotation, and then close that out. Now, to exit the loop, we have break. So, exit the loop based on user input. Okay. So, during this while, I'm going to say at the end of it, break, let's see, print now, let's say you entered and then throw recently user underscore input, because that is our variable user underscore input, and then close that quotation and then close that, and that should take care of that program. So now let's hit Control X, save, yes, loop. Now let's run this and see how it runs. Enter quit to exit. No, you entered user input. I typed that wrong. Okay, so now let's actually try this with quit. There we go. All right, now let's clear this out. Notice when I typed quit, it did quit. Okay, I'm going to clear so we can start that back clean, and let's take a look at what we actually did. All right, let's bring up nano loop.py. All right, so I'm going to take, based off the way that it printed that out, what I'm going to do is actually make this a dual print. So I'm printing out you entered and then the space, and then if I do a comma, I can print a second portion of this being a variable or even another text string if I want to. So user input is my variable, and since that's a variable, I don't put that in quotations. So let's see, print you entered with a space, user input, comma. Okay, so let's go ahead and hit Control X, Y, loop, yes. Now let me run this Python 3 loop.py. You entered quit, no, hit no. Ha, you entered no. That worked out well. Ha ha, I win. You no close. Okay, perfect. Now I'm gonna hit quit. Now it did quit. Alright, now I'm gonna clear that out. So that's how that works. Now I'm gonna open that back up so you can kind of look and see what we have. So while true basically just means it's gonna run forever. I left the count in there just from the previous version of what we were working on. And then user input, enter what do we want, or enter the quit to exit. So if you actually type quit, it checks that. If user input, which is the variable we established up here, equals quit, then it breaks. Break means exit the loop. And then since we have this loop going, once you break out of this loop, there's nothing left down here at the rest of the screen. So it just exits the entire program. So that's how you can make that work. So you can start a loop and then continuously run it until something happens, a condition of some sort. Okay? Think about our next steps here. So what I would like to do is let's get rid of a bunch of this stuff since we see how the user break can get out of the loop. Let's take these prints out, and instead of having while true, we'll go back to a counter. So we'll do while, let's see, count, I got an extra space in there, while count is, let's just go with less than 6. I'm going to start this over at 0. While count less than 6, and I'm going to do a print out. Print, let's go with, we are still inside the loop. Loop, and then close, and then let's actually print out the count so you can see where we are. Let's say with number, and then space, and then the variable count, and then we should close that. So while count less than 5, print, we're still inside the loop with the number. I got open parenthesis, close, I got open, quotation close, comma, my variable. Okay, now I want to increment, so count plus equals 1, and then I'm going to do else. And let's see, I did just notice since I opened that on else, I need to do, there we go. Now under else, I'm going to type print, open, we have finished looping, close and close. And let's see, now I also am going to use the time.sleep here, so we're not going to do it so quickly. Slow it down a little bit for the sake of watching. I don't know, let's just go back to 0.5, so it doesn't take too long. And this gives us the pause, okay? Now I think that should work. So I have a count starting at 0. I have the library of time inputted. While count is less than 5. Print, we're still in. Print out the variable. Increment count by 1. and then time.sleep. So I'm going to give a pause before the loop starts again. Once the loop finishes, it's going to hit that else. So basically, once this starts at 0, once it hits 5, then 5 is no longer valid based on this condition. So that means we go to else. So if this is not true any longer, else print we have finished the loop. And then let's also, for the sake of it, print exiting the program. And I bet you see what I already forgot to add there. That would be my quotations. And then now it exits. So that's going to be the last thing it prints. All right, Control X, say buffer. Now let's do Python 3 loop.py. We're still inside. Notice 0, 1, 2, 3, 4. Now, since that condition is less than 5, this is the last time that that condition is true. We have finished looping, exit the program, and then it exits the program and comes back to our command prompt. That is some basic information about looping. I like having that delay in there. I might do, for the sake of watching it, let's increase that delay slightly and just do another half a second. So make it a total of 1 second. Yes. And then loop. Let's see. Yes, 1 second. Okay, X. Now run that. Now you can see it runs a little bit slower, so it's kind of a little bit easier to see what's happening here. It goes 0 because it starts at 0, then 1, 2, 3, 4. Now the same thing like we did before, if we want to adjust your conditions and say, well, count is less than or equal to 5, then it's going to run. It should actually display 5 this time, as opposed to stopping at 4. So 0, 1, 2, 3, 4, 5. And then finish looping, exit the program. Now you can actually take this, if you would like, and integrate some of your math stuff in there. You can do some fun things there, where if the total equals at a certain amount, then it exits the program. There's some different things you can do along those lines. But that's the basics of how the loop works. Going back into the code, just to kind of review, you're always going to be working on a condition. So your condition is either true or some type of a condition that controls what happens as far as the loop. If you're going to be working off of numerical counting, you have to declare that count variable prior to initializing your loop. So notice we're doing the variable of count equals 0. If I didn't have this in here, this loop wouldn't work because count doesn't exist yet. And since we are doing sleep, we have to make sure to import time. It's a really good way to be able to control things. As we move on and start progressing into more and more complex code, we'll be doing more imports for the different libraries. When we start using Raspberry Pi sensors, we'll be inputting libraries to make use of those sensors. A lot of other fun stuff comes in. Once you get the general idea of how to use Python at the base level, then you just kind of continuously build on top of that, integrate the other libraries, start calling out, like say if we want to, let's say count equals 0, right? If I am going to use a sonar, which is something we're going to do in a future program, so like I say, so let's just make it distance. So distance equals 0 to start. Okay, so let's see if I want to do it that way. No, I'm going to say distance equals 50. So that's going to say 50 inches, for example. So I can say while distance, and this is where we're going to get fun. Okay, while distance is greater than, see if I can actually find the greater than while I'm looking at the keyboard here. While distance is greater than, we're going to make it 20. Okay? So distance starts at 50, and now count. I pushed the wrong button. Let's see. We are going to be moving into a different way to edit this code to make it a lot easier. So count minus, now I'm messing a lot of stuff up. It makes it more fun. So this is where I say when we're doing practice a lot of times, everybody messes up. It's totally fine. I'm doing it right here in front of everybody. I'm not editing this out so you can see that gigantic mess up when I pushed the wrong button and it messed up my code. We also need to take this print and throw that back down there, indent because we're inside of our loop. Okay, let's go back to where we were talking about things. So distance equals 50. So let's say we're utilizing a sonar. We're initializing distance as 50 just because that's going to be my sonar value in my hypothetical world. But we want to ensure that whatever we're going forward, if we're, say, using a tank bot or doing something along the lines where we want to make a condition change if something gets too close. That's where while distance is greater than or equal to 20, that means once it hits 19, it's going to die. So here I need to change count to distance because that's our variable. While distance is greater than 20, distance minus equals 20, so it should increment down. And then we are going to take this and do 0.5 and then print. Okay, and then once that happens, let's say, once the else happens, that means something's below 20, so it would be 19. We are too close to the object. Okay, and I'm doing this to kind of get an idea of where we're going and why some of this stuff matters. We need to stop exiting. Okay, so here you could just put like stop the robot. Obviously this is not the way that we're going to do it in the future, but if you have a sensor and we started off at 50 just because it's a hypothetical number and distance is greater than or equal to 20, then it's going to continue to loop. So that means we could be like, say, driving forward. Okay, but every time we loop, we need to refresh and see where it's at, but for the sake of demonstration, we're just automatically decreasing distance by 1. So basically it looks like you're driving forward and whatever you're looking at is getting closer. So I'm also going to run that again. Let's just go ahead and clear all this out so you can see how that works, and hopefully I don't have any typos in there. But let's see what happens. Yep, of course I have a typo. Oh, I do still have count in there somewhere, so let's bring that up. Oh yeah, right there. So I still have count in my printout, which obviously we're no longer declaring count ahead of time as a variable, so we have to change that. No big deal. Control X, Y, save. Now let's run that. Python 3 loop. Okay, so notice how it increments downward. So like, just imagine we're driving forward. We're driving forward with whatever robot we're working on. Whatever our sensor is seeing is getting closer. So maybe we're hypothetically getting too close to a wall. Once we get within 20, we got to stop or we're going to hit this wall. So in order for the robot to be able to take input from the sensor and make a decision, you have to run a loop continuously and check with that variable. And that variable is going to be something you're reading and continuously changing based off of the sonar input, but the concept is still the same. Now notice it just still says, as I have there with the regular printing, we're still inside the loop. We know that's happening. Now once it hits under 20, we're too close to the object, we need to stop exiting. Okay, so that's where this comes in. Distance just starts at 50, and then it continuously changes as you're getting closer. What's going to happen when you actually start using a sensor is you're going to take a live input inside of this while loop of what the sensor value is, and then make decisions based off of that. So if something does get too close, you can also then call a turning function. Instead of just stopping, you can turn 180 degrees and then go forward. So it's going to continuously drive around until it either hits something that it doesn't see or runs out of battery. So there's a lot of fun stuff you can do. Once you get the concept, now we've done input based from the user. We've done some mathematical equations. We do printout to the screen so you can kind of see what's going on. Now we're doing while loops, else's, and time sleeps and stuff like that. There's a lot of stuff. It seems a little bit simplistic, but you got to get the grasp of how this stuff works before you start moving on to the more advanced level. So that's what I have here for today's loop classes. As always, I do hope you learned something today. Please like and subscribe below. Thanks for watching.